Section 8.2 is on the reciprocal function family. Functions that model the inverse variation function belong to a family of functions whose parent is the reciprocal function, which is f of x equals 1 over x, where x is not equal to 0. Here's a little box from your textbook that kind of goes over some of the transformations that you can do. So here's the parent function, y equals 1 over x, x not equal to 0. So you can substitute the 1 on top for a value a. If the absolute value of a is greater than 1, then it's going to be a stretch of the graph. If the absolute value of a is a fraction between 0 and 1, or a value between 0 and 1, then it's going to be a shrink. And if a is a negative number, then the graph is going to be reflected across the x-axis. If we have x minus h in the denominator, that's going to be a horizontal translation. If we have a plus k outside of the fraction, that's going to be a vertical translation. Your vertical asymptote is going to be x equals h, because x cannot equal h, because that would be 0 in the denominator. And your horizontal asymptote is going to be y equals k. So all combined, it looks like this. Y equals a over x minus h plus k with x not equal to h. Let's take a look at a couple examples of what the graphs are going to look like. So here it says, graph each function, identify the x and y intercepts and the asymptotes of the graph. Also state the domain and range of the function. So for this one, we have y equals 3 over x. In order to graph this one, I think I'm going to start by graphing, or at least making a table for the parent function, y equals 1 over x. And doing a couple values for that. I want some negative and some positive. So if x is negative 2, then my y is negative 1/2. If x is negative 1, my y is negative 1. I'm going to throw a 1/2 in here also. So if x is negative 1/2, 1 over negative 1/2 is a negative 2. And notice my values are getting closer to 0. X cannot equal 0. So I'll put that in there. And now I'll do the positives of the same values. If x is 1/2, y is 2. If x is 1, y is 1. And if x is 2, y is 1/2. Okay, now to get y equals 3 over x, I'm going to multiply each of my y values by 3. So that's going to give me a y value of negative 3 over 2, negative 3, negative 6, 0 still doesn't work, 6, 3, and a positive 3 over 2. Okay, I'm going to go ahead and draw in my asymptotes here. I think I'll do those in a different color. Let's do those in red. So x cannot equal 0. So that's going to be my vertical asymptote here. Okay, so I have a vertical asymptote at x equals 0. I'm going to have a horizontal asymptote at y equals 0 because there is no value of x that I can put in there that's going to make y 0. So my horizontal asymptote is going to be at y equals 0. And let's go ahead and plot some points now. So I have negative 2, negative 3/2, negative 1, negative 3, negative 2, oh, I'm sorry, negative 1/2, negative 6. Okay, and actually I think I would like one more over here. You'll notice that they're kind of flips of each other. So actually I can also plot the point negative 6, negative 1/2. So there's half of my graph right there. And now plotting my positive values. 1/2 2. I'm sorry, not 2. Sorry. 1/2 6. 1 3. And 2 and 3/2. And I can also extrapolate that I would have 6 and 1/2 as well. Okay, so I've identified my asymptotes, x and y intercepts. This is never going to cross the x-axis So there are no x or y intercepts. My domain, x can be any number except 0, all real numbers except 0, and my range, y can be any real number except for 0 as well. Here's another example, y equals 1 over x minus 2 plus 5. I guess I could do this as a transformation of the parent graph by moving it, what would that be, 2 to the right and up 5. I think I'm going to start with the asymptotes. Go ahead and identify what those are. So I'm going to have a vertical asymptote at the value that makes my denominator 0. So I'm going to have a vertical asymptote at x equals 2 and a horizontal asymptote at y equals k at y equals 5. And I'm going to go ahead and graph those. Draw those lines in there. So here's an asymptote here at x equals 2. Notice that makes sense because I can never have a value of 2 for x because that would make my denominator 0. I have a horizontal asymptote at y equals 5. Okay. My a is positive, so that actually means that my graph is going to be up here in kind of the first quadrant area and down here in kind of the third quadrant area. Oops, wrong thing. Okay, how about my y-intercept? My y-intercept is what I'm going to have when x equals 0. So let's plug 0 into there. So y equals 1 over 0 minus 2 plus 5. Or my y-intercept is going to be at the value 4.5, 5 over 2. Wait, sorry. Yes, it is going to be at 4.5 at 5 plus negative 1/2 plus 5. Yeah, it's going to be at 4.5. And now for my x-intercept is my value when y is equal to 0. So when y is 0, I have 1 over x minus 2 plus 5, subtracting 5 on each side, and then multiplying both sides by x minus 2. So negative 5x is going to equal negative 9. So x is equal to 9 over 5, or approximately, no, exactly 1.8. So I'm going to go ahead and graph those points. So I have a y-intercept of 4.5, and I have an x-intercept of almost 2, so right there. So that actually kind of makes sense because I know part of my graph is going to be in this area. Okay, so I have those there. I'm going to make a table of values and just fill in a few values that kind of seem to be missing. I'd kind of like something in here. I would like to know what y equals and x is negative 1, or I'm sorry, a positive 1. Okay, and maybe that's probably enough there. So when x is 1, plugging in 1, I get 1 over a negative 1, which is negative 1 plus 5, so that's going to give me a value of 4. Okay, and I think that gives me enough to kind of sketch what my graph is going to look like here. But unfortunately, my x and y-intercept didn't give me any values up here, so I'm going to have to pick a few values that are going to work over here. So I think I'm going to go with, let's see. Okay, so let's see, how about right here? When x equals 3, plugging that in, I get a value of 6. So that's going to be 3, 6, which is good. I think I'd like one a little bit closer, something up here. So when x is actually 2.5, y is equal to 7. So that's kind of nice. And then let's do 4. How about when x is 4? Plugging that in, I get that y is 5.5. So when x is 4, y is 5.5, and that's really good because that's approaching my asymptote right there. Okay. All right, so let's see. So I have my vertical and horizontal asymptote. I have my x and y intercept. I do need my domain and range. My domain is going to be, domain is going to be all values of x except 2. and my range is going to be all values of y except for 5. And because this video seemed to be getting a little bit long, I went ahead and I did our third example for you. Okay, this is y equals 2 over x plus 6 minus 1. So my vertical asymptote is x is equal to negative 6, because that would make the denominator 0. My horizontal asymptote is y equals negative 1, because that's my value of k. Okay, so I went ahead and I drew those asymptotes in there. Because A is positive, I know again that I'm going to be kind of in the first quadrant area and the third quadrant area. Calculated my y-intercepts. My y-intercept of negative 2/3 and my x-intercept of negative 4, and that actually gave me 2 points for this section of the graph. So I went ahead and I picked a couple more so that I could get the curve going up this way. So I picked y equals negative 5, which gave me a 1, and y equals negative 5.5, which gave me a 3. Then I needed some points for this part of the curve because I didn't have anything for my intercepts. So I did negative 6.5, which is this point here, gave me y is negative 5, negative 7, which gave me 3, and negative 8, which gave me a negative 2. So basically what you want to do is once you've got your asymptotes and you've got your x and y intercept, you know what your curve is going to look like. You know you're going to have one swoopy part in this quadrant and then one swoopy part in the opposite quadrant from that. Then you need to pick some points around your asymptotes, particularly around the vertical asymptote, to get a few points that are going to make that actual swoop of the graph. So in this section we took a look at the reciprocal function family, basically the function y equals 1 over x, and how we can translate that and how we can go about graphing it.